Did it work? Maybe? Cross fingers? It did. Okay. So we do simulcast here on Twitch and YouTube, but for some reason the YouTube side would not launch earlier, and I just reset it again, and now finally it's working. So, yeah. We haven't been up all that long today, though, so I don't think there's that much missed there. All right. So, questions, because ads are dead now. Do you use Tree Sitter for syntax highlighting? Yes, I do. And it's very good. I like it a lot, actually. I checked your free list allocator. Can I ask why that over malloc? I figure it's hard to beat malloc speed-wise. So, there's a couple reasons behind it. I can control the way that allocations are made in terms of memory layout. So eventually what I'm going to do, and I haven't done it yet, is I've got all those tags that I have on allocations. And what I'm going to do is use that to split those up to different blocks of memory. So that way they're all contiguous in memory to try and avoid cache misses, right? So if we're looping through the same type of data that's dynamically allocated, I can control where those are in memory and group certain things together to be able to process them faster, is the idea behind that. And it also allows me to do things like eventually I'm going to have analytics on like memory fragmentation, as well as I've got reporting on like what tags are using how much memory, things like that. So there's a couple of reasons behind that. Also, you have certain environments like consoles, for example, that don't like just memory fragmentation or memory being pulled from wherever. And they tend to be very unperformant in a scenario where you just malloc everything in place, right? And so I am eventually going to port this to consoles, so I'm trying to kind of do that with that in mind, right? PC, it doesn't really matter as much, but on consoles, it definitely can matter. So I hope that makes sense. All right. I think I got all the questions. Cool. All right. So what we are debugging at the moment is we basically have all these messages that are saying that we're using one type of image view against a different type of texture. And I think I've found one place that seems to be the source of a lot of these problems. So, Malware Corporation 97, I love the name. Thank you for the follow. So basically what we did, one of the last changes that we made was when we first set up our cascading shadow maps, we had them writing all to different depth textures, right? We had 4 different depth textures. And the problem with that was, obviously, that's not going to be quick because it's different textures, right? But also we had a separate sampler for each one of those textures. And what we're changing to now is we're using an array texture to hold that instead, which obviously means that in places where we had multiple textures holding the shadow maps, that's obviously going to be wrong. And so the issue there is basically it was clobbering some of our other textures in our other channels, and was basically putting the wrong stuff in the wrong place. So like our material textures was having a skybox attached to it, and our some of our other material textures in the gigantic array that we have is getting the shadow maps placed in it, just because I think we're basically clobbering arrays that are further down in memory. And so that is what I'm working on fixing now. It was kind of an interesting little bug to find, for sure. All right. Let's see, over on the YouTube side. Okay, it looks like that is working now. So started watching your series, hoping to learn a lot. Appreciate that, and welcome. Hoping you learn a lot as well. And I would also say that the purpose of me doing it this way versus just a flat tutorial format is you guys can see like when I mess up stuff and why I mess up stuff. And you know, I think that troubleshooting and debugging is an important process that a lot of places skip over. And so I want to make sure to sort of highlight that here on this channel, right? All right, so I can compress this down to a single texture. So this is just a sort of configuration that we build out in order to build out our resources that we need for each of our maps. So technically speaking, I don't even really need this to be... Let's see. This is only done on load, so I'm not really worried too much about fragmentation here because it's thrown away afterwards. So I think I'm going to keep that as is. Let's see. So maps, SAMP terrain shadow map. Plus I. So we don't need that anymore. Alright, so that's going to be at index 20. Loaded into the first and only texture map slot for shadow textures. Okay, so that should fix that one. We have the same thing already here for our irradiance map. Okay. Now I know that was done in a couple of different places. Yeah, here's another one. So this is where we're actually applying it to the material, which is also going to be wrong. So we don't want to do this. We don't need... The index is just going to be 0 in this case. And this is just state point shadow textures. What is... I think that's an array that we might actually need to change. Yeah, this is an array, which should just be a single texture now. So we're going to change that to a single texture. The current shadow texture to be used for the next draw. Okay. So this is just a single texture now. I really ought to make like a utility method to be able to do this a little bit simpler and not have to retype that all over the place. Should probably change that sometime soon. All right. PBR location shadow textures. That is correct. This is not arrayed though. So we don't want the arrayed version of that for this. The irradiance map should be Pop Nemo and Yarn Nito. I love it. I love those emotes. Those are some of my favorite ones. You started streaming in the morning in the US. It's 17:42 here. Usually watch to 3 a.m. Yeah, so I'm doing a little bit of an extra stream today. I normally don't stream on Saturdays, but today I am. And yeah, the YouTube side got started a little bit late because it didn't want to launch over there for some reason. Like I kept refreshing and it just didn't want to launch. So, collector of stuff, thank you for the follow. Appreciate that. So this is going to be, oh, wait a minute. Material maps. This isn't going to be correct. This needs to be... I actually do need this index. This was... This was terrain shadow, not terrain shadow map. Should have just been SAMP shadow map, I think. Which I think I actually nuked and should not have. I do actually need that. U32 SAMP shadow map. That was going to be index 5, and then U32 SAMP irradiance map is going to be 6. Okay, so the map's index needs to be that. But it needs to go into the first texture slot for the shadow textures. Okay, that makes sense. All right. So for the irradiance map, I rename this to irradiance map. Same down here. In case you guys are wondering about the music, by the way, this is the music from Heartbound, which is Pirate Software's game in development. In case you're wondering where that's from. Let's see, I did my own free list allocator recently, one of those with the header at the start and end of each block. It's super difficult to debug when something goes wrong. I wonder which tools you use for that, or is it just a skill issue? Yeah, so, I mean, it was basically one of those things that I wrote a crap load of tests for, and just debugged my way through those tests, and once it was solid, I didn't really have to touch it again. But yeah, I just kind of debugged it like the normal way through using the VS Code debugger, right? When I wrote that, I was still using VS Code, right? So I still use that to debug. And I still use that as my debugger, but I don't code it anymore. So yeah, I mean, I don't use anything super fancy for debugging unless I'm doing GPU related stuff, and then I use RenderDoc. But yeah, I don't use anything fancy, which may or may not be a good thing. You know, maybe there's something better out there I could use, but I don't have anything fancy at the moment that I use. I tend to write a lot of my debugging tools into the actual engine over time. All right, so there's our shadow maps and our... You know what? I don't even need this index business. Let me just do this. Because we aren't iterating that anymore. So we have that for our PBR shader, and then for our terrain, we actually have to do kind of the same thing. So we have to get rid of this loop because we're not dealing with multiple textures anymore. And then this is just going to be SAMP terrain shadow map, because that's going to be at a different index. SAMP terrain shadow map. Get rid of this. And this is going to be just shadow texture now. And it's not going to be indexed, so we need to use the non-arrayed version of this. Okay. Oh, I think this is still technically called shadow textures. Okay. So that's the shadow map. The SAMP terrain irradiance map, I don't think that needs to change at all. That should be good. Okay, we're not using the arrayed stuff for that. And state pointer shadow textures. Okay, so shadow map sets had an index before, which we don't now need. So I might wind up actually getting rid of that. But for now, I'm just not going to use it. So we're just going to say that for right now. Irradiance sets, I don't believe has to change. Okay. So this is the load material. When we load up a material, SAMP IBL cube, this should just be a radiance cube. A radiance map, rather. Eventually we need to have irradiance probes in the scene. That's what that's for. Alright. So the shadow textures for the PBR material. This is going to be shadow map count is going to be 1. Don't need this array. And then it's going to be just SAMP shadow map. We don't have multiples of those anymore. Wait, what is this bleating about? M maps, is this a pointer to a map already? It is. Okay, so we set the first index of that. That should be fine. Let's see. Hi, is this where everybody is hanging out? I think so. Yeah, which is fine by me. Welcome, welcome. Let's see. Let me catch up on the YouTube chat over here. If I can expand it so I can actually read it. Stream for the sake of getting it to run again, hopefully. Yep. Can't wait to see what you're making. The physics simulation parts. I'm thinking about which method to apply collision on so many objects moving, which is a real life issue. Yeah, that's going to be an interesting study, right? So we're going to try a few things with that. I've got some stuff in mind there. Currently using 2 depth textures for static objects and 1 for real-time moving objects. Okay. Did I... What does that say? Did I put PBR textures into 1? Not yet. So we're actually going to write a tool to do that. So right now, our PBR textures are all separate maps. That's obviously not ideal, right? Because they only really require 1 texture channel of data. And so we're going to write a tool that will sort of combine those for us. So thank you guys for the follow, by the way. Appreciate that. Give me 1 second. I just have to take care of something really, really fast. Okay. So, let's see. So shadow textures, we've got that straightened around. This is going to be a radiance. Not the terrain version of that, just the regular one. Okay. Let's see, what else? So this is, again, a radiance. PBR, I don't want the terrain of that again. So I'm basically just remapping all of the textures that we're using different... oh yeah, we've got a couple of... let's see, clamp mode on the default shadow map to border. So we only have 1 shadow map. So we need to basically get rid of anywhere that's looping this. Okay, that one should be fine. Get rid of these guys. Okay. And we've got more shadow textures here. That was using hard-coded numbers anyways, which wasn't great. So now this is basically just using 1 map. All right, sampler shadow map, that should be fine. And then this is a radiance again. Why do I keep getting the terrain one? Okay. Clamp to uniform configs. Okay, that should be fine. I feel like there's probably still a couple of these that we're missing. So this is again shadow textures. This is now creating a default terrain texture. That's why this kind of looks similar to before. I am going to condense this so that all this logic is in one spot, because now that's like 80% repeated logic, which isn't great. Okay. Radiance cube. Shadow maps can't be configured. Okay, so we have multiples here. We don't need multiples anymore. We just need the one. All right. So that's that. Hoping. Let's build that out and run it and see where we get. I feel like we might have missed a loop or two, but we'll run it and see exactly what we get. Probably a much more validation errors, but that's kind of what I expect to happen at this point. Yeah, okay, I thought so. All right, so uniform texture maps, texture. Index 2. All right, so how did we get here? So we're acquiring instance resources for the default PBR material. PBR shader ID. Okay, so we've loaded the shader. Okay, we have an internal ID, which is good. It's not invalid ID. So what is this? What ID did it pick out? 0. Okay, that makes sense. So the config texture maps index 2. Which one is this for? Uniform location 13. I'm guessing this is the default textures that it's using. Yeah, default diffuse. So per descriptor, how many samplers do we have in here? We have 3. Why do we only have 3 if this is a... Let me look at the configuration that we generated for this, because I'm thinking that's probably where the issue is. So this texture map count for this guy is 5. We have the 5 maps here. So let's take a look and see what's in this array. We do have texture addresses all the way down. Default AO. Okay, so this is all default textures, so that's what I expect. Okay, so it's not that one. Let's see, so for shadow textures... That is uniform location 13. So this is the one it's choking on. Texture map count is 1. So we're uniform config. Texture map count is 5. Okay, what am I missing here? Because that should be 1, not 5. So we've got our 3 configs here. This is the first one. This is the second one. This is the third one. But I don't see anywhere Wait a minute, didn't that just say 5 a second ago? Am I losing my mind here? Let me catch up with chat real quick. Should I learn C or CPP? I want to learn the language which suits for mostly all purpose. Can you please tell? I have experience working in Python and Java. So the way that I would say technically learn both. But the way that I would do it is I would learn C first and then learn C++ from there. The reason for that is because C++ is basically much more complex than C. But if you really have a strong grasp of C, learning C++ will be a lot easier. But if you try and do it the other way around, it might not be as much. You'll probably wind up getting overwhelmed with C++ if you just start with that. And C++, especially modern C++, tries to hide a lot of things like pointers from you, and especially how they work. And I think that you'll have a much better understanding and grasp of it if you start with C. That kind of forces you to use that and then go to C++. I'm currently watching video 60 of the Kohi series. This stream spoiled me that VS Code seems to have been replaced by Vim. So it hasn't been. It's just what I use, right? So the configuration for VS Code is still there. So that's not going anywhere because I know a lot of people do use that. I just changed to a different editor, right? That's the only difference. Let's see. C++ is like C with a bunch of additional things. Exactly. Yep. You can learn the basics of C, then move to C++ to get more features that ease the process of programming. Yeah, exactly. Yep. Both of them are general purpose, and you can do anything you want with them, of course. Yeah, exactly. Yep. Agree with that. All right. So let me see over here on the YouTube side. I'm a beginner in graphic stuff and currently learning things on GPU architecture. Where do you say that I should begin with in the software part? I have programming experience mostly from web dev. So if you haven't really done any graphics programming before, I would say probably, even though it's kind of deprecated, I would still probably start with OpenGL. And the reason I say that is because it's a lot quicker and easier to get things up and running. And you could focus on some of the actual concepts behind graphics programming. Whereas Vulkan, there's a lot of other things you have to kind of bear in mind in order to get to the same point with it. That being said, I would also limit the amount of time you spend with OpenGL and move to Vulkan as soon as you can. But I would not probably start with Vulkan. I would start with OpenGL, frankly. I hope that helps. All right, so why is this then? So we have the sampler state texture maps times array length. Why do we have an array length of 4? Oh. I wonder. The PBR. We have ads. So I'll break for that real quick. We'll just break for that for 90 seconds, right? And then we'll be right back, just because I don't want you guys to miss anything. So we got about 30 seconds left on ads, and then we'll get back to it. The music is horror. Yeah. It's the soundtrack from Heartbound, which is a game that is in development by Pirate Software. And it's got a range of. It's an RPG, so it's got a range of happy music and sad music and all kinds of different stuff, right? All right, ads are dead, so we can continue. I skipped OpenGL and went straight to Vulkan. There's a lot of resources from GPU vendors to help get started, and I hated the OpenGL API on first sight. Yeah, I agree with you there. I'm not a fan of the API, right? But the reason I'm suggesting that is because most of their experience is in web dev, right? So if you're already trying to learn C and C++, trying to learn Vulkan on top of that, you're just asking for pain, right? So you really want to focus on one thing at a time. I normally would agree that if you already have the experience in C and C++, one or the other, then yeah, go straight to Vulkan. But if you don't have experience with that either, then I would limit how many new things at once you're exposing yourself to. You learned C while trying to learn Vulkan? Nice. I mean, it's certainly possible. I switched to C from C++ when I was learning Vulkan. Switch from C++ to C. Okay. Yeah, that's part of the problem right here. So in our PBR material shader config, we didn't change this. It's a sampler 2D array now, instead of an array of 2D samplers. Terrain. It's probably wrong in this one as well then. I wanted the shader config for that. That one. Yep. That's part of the problem. So these files are essentially metadata for how the shader is actually configured, because I don't have shader reflection working yet, right? So this basically tells Vulkan how to build the pipeline, or tells the renderer how to build the pipeline. And so the shader basically just needs to match up with this, right? Not ideal, but eventually this will be replaced by just shader reflection, and we'll be able to work that way. Okay. Honestly, I'd like to have a defer feature like Go has for future C versions. I'm not sure what the defer feature is. I'm not too familiar with Go, I will admit. So I'm not sure what that's all about, but what kind of features would you like to find in future versions of C? I can't really think of anything, to be honest. Like, C is kind of good as it is, right? I would hate for it to be I would hate for it to get feature creep like C++ has had, right? The feature creep of C++ has been awful. Oh, defer equals run this on scope exit. Okay. Does all the code inside his body on scope exit. I gotcha. Okay. So what is shader reflection? Can't drop that buzzword and not explain. Fair enough. So basically what reflection would be analyzing... let me pull this up. It would basically be analyzing this particular shader and saying, okay, well, we've got these structures defined. We have these layouts defined. We have these uniforms defined, right? And then automatically taking these things and creating metadata from them in memory, instead of having to create a metadata file to go along with it, so that we know just by reading the shader file what the layout of the shader is, instead of having to also configure that in a separate file. So it is something that I want to do in the future, but that is, in and of itself, it's kind of a big task. So that is basically what that's... yeah, it's explicit and optional RAII. Okay. Finally caught a live stream. Awesome. Welcome. Okay, so with this, that is now fixed. So that's probably part of the problem. All right, so let's run again. Breakpoint, don't need that. Okay, so we run, we load this up. Let's see what we get in terms of errors. A few things. Looks like we might have solved that other issue. Okay. In fact, you know what? Let me look at this not here, but also in the editor so that we can see this a little bit more clearly. So cannot bind invalid instance ID. So that's probably an issue we need to look at. We only have 3 issues this time, so it looks like we knocked some stuff out. Okay, so this is about a descriptor sets skybox view. Oh, the skybox might be wrong. Descriptor sets in bindings 1 and 2. Index image view is type cube. Okay, so that's a type mismatch again on the sampler. Okay, so that's probably a configuration issue as well. So, skybox, oops. In the shader config. Let's see, we do have that listed as a sampler cube. It's instance, okay, so I don't think that's the issue. Maybe the issue is in the shader itself. Oh yeah, this is just an array, which it doesn't really need to be. So there should be sampler cube. And then it is using a 3-dimensional text coordinate for sampling. So maybe that was the only thing that was. Let's write that and rerun this. Okay. So that failed to compile. Let's see why. It's not an array. Oh, did I forget to take away the index? Yes, I did. So we really don't need this. We don't need that. We should probably just call this... Let's just call that cube texture, right? Okay, boot it up that time. All right, so now we have a few other things to add. Different set of errors this time. Okay. Oops. This one. It's probably going to be all the way to the bottom. Okay, terrain instance. Here we go. So image view, descriptor sets, binding 1 and 2 index 0. These are both saying that they're image view of type cube on an image that isn't a cube. Okay. And what is this last thing here? Because I wonder if that's related. That's standard UI. Descriptor sets, descriptor writes failed with update validation. Write update to descriptor sets. Allocated with layout blah blah blah. Failed. Oh, failed to update a sampler with a void sampler. Okay, well that's not ideal. Okay. All right. So this this first one was in the terrain. The terrain shader. So let's take a look at that because maybe I didn't switch something over. in the fragment shader as I should have. So that is a sampler 2D array. Shadow texture. Yeah, I've changed over all of this. But which one was that saying? That was saying descriptor sets the instance frame 0. So in binding index, so binding 1 and binding 2 index 0 on both. So binding index 1 and 2 is basically these. Oh, okay. Yeah, I didn't update this size. That should be that. No, actually it should just be... Oh wait, no, that is right. 5 times max terrain materials, which would be 4. Yeah. So that should be 20. No, that is right. This is one of those things that, like, once I get it, I'm probably never going to have to touch this again, but getting it there is going to be the challenge, right? Config is what I want. So that is an array of 20 sampler 2Ds. Sampler 2D array. Okay. These are all instance scope. So those should be fine. I wonder if that just means that I've missed like one of those loops that I was thinking about. So if I go up here to the top, RDS Twitch, thank you for the follow. Also, Auto Prez, thank you for the follow. Appreciate that. So we have max shadow cascade count. Let's do cascade count. Directional light space. Okay, that one has to stay. This one doesn't. Here's one I missed. Okay. This one should be, and it is in the terrain shader too. For terrain materials. So I did miss that one. That's probably the entirety of the issue. Light space. Okay, that one is fine. Light space, that's fine. Yep, here's another one I missed. So I need to get rid of that loop. And also the default shadow maps. There only needs to be one of these now. So we only have one texture. Okay, we've gone through the whole file, so let me build this again. Does the name in the shader have to match what looks like a name in the shader config? Yeah, well, so when we let me pull up a shader config. Let's do the PBR. So the name that is in here ultimately has to match what's in the file for now. This is just really for me to verify that we're loading the right one, and that I'm not doing copy pasta. So when we say we want to load a shader, what we really load is this file. And then this file says, okay, we support these stages, right? So vertex and fragment. And then we have these stage files, which align with these stages, right? So for the vertex, we have this vert GLSL file. And for the fragment, we have this frag GLSL file. So these files could be named whatever, as long as that name is correct in here. And then we have these other instances, or these other variables that we can set. So max instances is basically saying how many descriptors do we need to create. Potentially what's the max on that, so we know how much memory to allocate for that. Depth, right, and test are kind of obvious, right? And then this is our attribute configuration for our vertex attributes. And then our uniforms are here. So we have 3 scopes in our shaders. So the first one, scope 0, is global, which means it essentially gets updated once per frame. And then we have instance, which is, you can think of that as a material instance that gets updated per instance of a material. So let's say that you have a scene full of 10 objects. 5 of those objects are metal, and the other 5 of those objects are wood. You'd have 2 materials, right? Which would mean you'd have 2 instances. So per frame, you would update global once. Instance, there'd be 2 of them, and then for local, that would be per individual object, which would be 10. And so the format of this is the type of the uniform itself, the scope that it's at, and then the name of it, right? And then that's basically just how that works. And if it's arrayed, we can also include that as part of the type, right? So that's basically the way that that works. If we have some sort of special struct, instead of just using one of these primitive types, we can also say here we have a struct that's 32 bytes, right? Or 480 bytes, right? And so that's what that struct is to allow us to sort of say this is how much space we need to reserve for this thing. You were thinking about these shadow textures at the end of the uniform equals line. So you're thinking about this guy here. So does this have to match what it looks like? I'm using explicit bindings, yeah. So when we go to get the location of that uniform, it's based on this name, but technically it could be named something else in the shader. It doesn't have to match what's actually in the shader. And that's what I meant by shader reflection when I was talking about that earlier, is eventually I want to generate essentially this configuration by looking at the shader files, essentially. So I hope that makes sense. RDS Twitch, hello. Sensor Effects, good morning. Good to see you. Hamster Dev, good to see you as well. Let's see. Wanted to ask, I remember you did a video like the state of Kohi. Are you planning to do another one? Talking about the engine, what was accomplished, and what was coming. Yes, that is in the books, actually. I just have to record it, frankly. Find time to record it, right? Which plugins for NeoVim do you use? Which do you find the most useful? So what I'm going to do is put in chat, assuming my chat bot on the YouTube side works, which sometimes it does, sometimes it doesn't. There is my NeoVim configuration for you. So there's a link there. You can follow that. And I've got a detailed explanation of exactly what my setup is here. It's slightly out of date, but it's like 95% accurate, I would say. What happens if the name doesn't match? You mean of a uniform? Right now, it doesn't matter. What matters most is the order of these uniforms, the type, which ultimately determines the size, and then the scope. So this name here doesn't have to match what's in the shader file, but when I go to pull the uniform in code, it has to match. And if it doesn't find it, it'll actually complain about it and throw an error in the console. We'd probably hit a validation error because Vulkan needs you to specify exactly what resources the shader uses. Yeah, exactly. That's why we have this set up, is to get around that, right? So this is ultimately built for that purpose, right? The pipeline layout and all that stuff. Let's see. The name is only for the compiler, I think. Yeah, the name is only for... in this case, it's only just to get the actual location of where this is in the list, essentially. The binding is encoded in the shader config by the ordering. So this actually does not specify binding any more than... This is more like descriptor set, right? So our global is always like the first descriptor set. Unless we don't have globals, then instance can be. And that was one thing that we recently refactored too. So you could theoretically have a shader that doesn't include globals or doesn't include instances, right? And then locals are push constants. And so think of this more as the descriptor set versus the descriptor binding itself. And then as far as the standard uniforms are, like for the base types right here, all of this essentially is passed in as a contiguous block of memory from the CPU to the GPU. And then these samplers here, each one of these sampler lines have their own binding. So basically the way this works is all of this stuff up here in that scope is one binding. And then this is another binding, this is another binding, this is another binding, right? And those bindings are also per scope. So all of our base types, like mat4, our vector types, our U32, all that kind of stuff, all of those go into the same binding. So we call that the UBO binding, right? So we just kind of load that into one contiguous block and shove the whole thing over at once when we apply it. All right. So I think the last thing I did was I built this, and then I don't think I reran it yet, I think. So let's see what we get. I'm still kind of expecting an error here because we didn't fix that last issue. Did I not rebuild it? I might not have. Skybox view. Did I not rebuild it? Might not have. Yeah, no problem. Let's see. Currently learning C++ since you're much more comfortable with OOP from Java. Yeah, so we don't do a lot of OOP here, but yeah, I get that. Breaking out of the OOP mindset is not an easy thing to do. Aim for learning C later. That makes sense. Do whatever you're comfortable with, right? That's ultimately what matters there. Okay, let me try running this again. I'm wondering if maybe there's didn't solve it and the issue is actually somewhere else. Okay, apparently the issue is somewhere else. So let's take a look at this real quick. So we're talking about the skybox view. Okay, so in binding index 1 and 2, or binding, I should say binding 1 and 2, index 0 on both, the image view type is cube, but the image is a 2D non-arrayed image. What would cause that? And that's in the terrain shader, I think, still? Yeah. Let me think about what would cause that. So, I guess while we're talking about the way that the bindings and stuff work, like when we pull shader locations, this is the code that does that, by the way, right? So we save off all these uniform locations, and these names have to match what's in the shader config file. And the uniform locations are just a U16, right? So we save those off, and then when we go to apply those later, find a good example of that actually. So when we apply instance, for example, we could say shader system uniform set by location or location arrayed for arrayed types. And we can just pass whatever that location is in the shader, and then we pass the data, right? So it becomes pretty simple to set this. And the way that this works is For instance level bindings, we have a block of contiguous memory, and based off of where this uniform sits in that list, that's the block of memory it gets written to. And then when we go to update the descriptor, it updates that whole block of memory, right? And that way we don't have tons of blocks of memory that we're sending to the GPU. It's much more efficient to just have a single block of memory and say, if this was updated, go ahead and throw the whole thing over to the GPU. All right. So this is bleating about the terrain shader. So let's see. The sampler count here is 5 per material, which is 4. So that's our 20 material maps. So that makes sense. Our terrain shadow map should be index 20. It is. Basically, if we have a shadow texture, we bind that. If we don't, then we use a default texture. Same with the irradiance map. And so our terrain locations, shadow textures is where the shadows go, and the IBL cube texture, which I really need to rename that, is where the irradiance map goes. So I don't see anything wrong with this per se. This is no longer arrayed, so it should be fine. None of this stuff has changed in ages, so I don't think it's that. It is definitely at the instance level that it's happening, though, so let's look at... Actually, that wasn't bleating about the shadow, was it? It was bleating about... Index 0 of binding 1 and 2. So this is the material textures and the shadow map textures, which for some reason is getting the cube map assigned to it. So when we set the shadow map, we just set the texture as is. That shouldn't be... We ignore the index. Same for this. There is no index with that. That's fine. I wish I could tell. Let's see. Do we have anything in here that tells me what material ID this is? Because that might actually help. I need to find out what's doing this too, because I wonder if that's part of the problem. Let's see. Actually, I legitimately wonder if that is the issue. We have ads. Recently, I read a bit of the Kohi for learning purposes. I admit source code is so clean, anyone who could read it. Anyone that reads it could enjoy. I appreciate that. Yeah, I try to keep it clean. There's still plenty of nastiness in there that I have to clean up for sure, but I try not to check in any stuff that's like too messy, right? Like when we get this up and running, we're going to do definitely a cleanup pass on it for sure. Riley, hello. Good to see you. Maybe the issue is caused by some undefined behavior or using sanitizer. No, I'm not doing a sanitizer at all. I don't think it's undefined behavior. I think it's because we literally just ripped apart the whole system that deals with descriptor sets, bindings, uniforms, all of that. We basically just ripped out that whole thing and redid it. So this is just fallout from that. And we're getting close, I think. Like you saw earlier we had a whole list of validation errors, and now this is what we're down to. So, yeah. Ads are just about over. All right, ads are dead. It's getting bound incorrectly, yeah. I think that's exactly what's happening. It's just getting bound incorrectly. Let me take a look at the... Let me look at the shader config for Skybox. Because that's the one that seems to be the one that it's complaining about, right? I think that's what it was anyway. Oh no, it was terrain. It's the binding of the skybox to the terrain. Okay, it's terrain again. So it's not that. So it's basically complaining about this one. But it's also saying index 0 of this binding and this bind. Oh, you know what? Let me take a look at the fragment shader, because maybe I screwed up something in there. Wait, that's the wrong one. That's the shadow map pass. Terrain. This is the one I want. So it's literally saying index 0 of this binding and index 0 of this binding are a cube for some reason, which is only here. So we have set 1, binding 2, binding 3. Shadow texture. I don't think any of these are wrong. Nope, I think those are good. But it's saying it's bound to a cube view. The only one that uses a cube is this guy. What does the irradiance texture just uses? It's sampled here and that's it. This is the only other place that I can think about that might be doing it wrong. So load material sample, irradiance map. This is in load material. This is for PBR, so that one's actually acting correctly. Default PBR material. Default terrain material. Uniform configs index 2. One map. Terrain irradiance map. What index is that supposed to be? 21. Yeah, that's correct. So let's see where this is being assigned. That looks correct to me. Material counts. require terrain material. It feels like there's something in here that's just wrong. Unless it's being applied wrong somewhere. Let me see. So, hi, is this your day job? No, it is not, unfortunately. I'd love to do this full time, but yeah. No, I do. I do graphics programming that's web-based for my daytime job. And it's a mix between that and standard application maintenance, right? Can you give debug names to descriptor sets like you do for image views? Yeah, so they actually have, they actually do have them. So this is how I've named that there. So descriptor set shader built-in terrain. So that's the name of the shader, and then it's instance level, and it's frame 1, right? So it tells me exactly where that aligns with that. So we do actually have names from that. So that's how I can tell like what shader it's actually trying to do this in. So I know for sure it's in the built-in terrain shader at the instance level. And then if I look here a little further down, we have, see, and this is what's confusing to me though. I'm wondering if something in our skybox shader is actually doing something wrong, but this tells me the view that's being used, right? So that is our skybox, which we're also kind of double using as our irradiance map right now, which isn't 100% correct. But it kind of gets us close to where we want to be. And so we're using that view, but for binding 1 and binding 2, index 0, which is wrong. So that's what I'm trying to get to the bottom of now. It's basically just, it's using the wrong view for some reason, which means that the texture is being bound incorrectly for some reason. And to back this up further, our last render doc capture that we took, the very first thing here in material textures was skybox. And so that's just obviously wrong, right? Let's see. You were wondering if it was a stale binding because of the skybox image. Yeah, I don't think it's so much a stale binding as much as it might be off on an index, or maybe it's getting clobbered from somewhere else. I'm not 100% sure yet. Because before we had an array of textures that was being written to something that was no longer an array of textures. But this does not seem to be that. So for some reason, and actually this is not the right section, we should be looking in here. So this is the terrain shader where all that binding happens. So we're taking the maps out of the material at index 21, and we are binding it to where the IBL cube texture should be in the terrain shader. And all this is doing, all this line here is doing is just making sure that there's something bound there, right? So if it doesn't have, let's see, wait a minute. Yeah, so if we don't have a currently assigned irradiance texture, then it just kind of grabs the default cube texture that we created in our texture manager. So I'm just thinking there's something here that we're just not doing right. And it's not popping out to me yet. I'm sure it will, but it's not yet. What app am I using the code? You mean this one right here? This is NeoVim. So yeah, I've got a whole configuration for that actually, and an article I wrote on my website. I'll drop a link there in chat. Isn't that error saying it's expecting an image view of one type, but it's getting an image view of another type, essentially? Or what it's saying is I'm using a image view of one type to sample another type, basically. So, in other words, it's saying, hey, you're using a cube view to sample what should be a 2D texture. And the reason for that is because of what's being jammed into here, right? So this is an input for the shader, and it's jamming the skybox in as the first material texture, and it shouldn't be. So I'm just trying to figure out where that's happening. In fact, I should probably take a new render doc image, right? Actually, I don't even know if I'm going to be able to do that before it crashes. So maybe not. Easy hack, just make the skybox a cube map. The skybox is a cube map. Yeah, that's the problem. So, the problem isn't necessarily with the skybox itself, it's the terrain shader's use of the skybox, because the way that this should be working is, let me maximize this. So, the way that this should be working is we should have all of our material textures first, right? And I fixed this problem with these depth textures, right? That was getting jammed in there as well. So this should be an albedo map, then we should have a normal map, then we should have a metallic map, then a roughness map, then an AO map, right? And notice this AO map is correct. So these first four were wrong. I'm pretty confident I fixed these three, but this one here is still wrong. And then we have the next material, which has albedo, normal, metallic, roughness, AO, right? And so we go through all of that, and then all the way at the end, we're supposed to have our radiance texture is the skybox, so this is correct. But then I don't see our shadow map texture here in this either, so that's also wrong. So I just have to figure out why that is, essentially. Unreal Apprentice, thank you for the follow. Appreciate that. All right, so I wonder if I can get. I'm probably not gonna be able to get a capture quick enough. Let me see. What was that? What was that third? Because what it's actually crashing on. Maybe I should focus on this one next, right? So the standard UI instance frame 1. Descriptor sets fail to write validation. Failed update validation. Descriptor sets with error. Write update to descriptor set. Instance. Binding 1 failed. Oh, because we don't have a sampler there. So maybe let's fix that one first so we can at least run. And then we'll come back to this guy. So that tells me, let's see, what index was that again? Where was it? I thought the binding index was here. P descriptor right. Maybe not. Okay. Let's take a look at the shader config for this guy. So the only thing that we have here is we have a global projection of view matrix, a structure, which is instance level for some properties, and then a instance level diffuse texture, and then a local level model. So there's not much in here that should be a problem. That's just a single sampler 2D, so I'm not really sure what is going on there. Take a look at the fragment shader. So that's set 1 binding 1. Set 1 binding 0 is our local uniform object, which has some UI properties in it, which will obviously expand. Do we have... in the vertex shader, we have the set 0 binding 0 for the global uniform object. And then we don't have any samplers in that one, so we shouldn't have a binding 1. So let's have a look at standard UI and see if we can figure out where this issue is. Sorry, Enigma. Thank you for the follow. Appreciate that. All right. So, yes. So, thank you for the follow. Appreciate it. Welcome. All right. If we do we not have locations in here? I thought we did. I don't think we have. I think I stripped all the material system stuff out of this as well, so that shouldn't be an issue either. Thank you all very much for the follow, by the way. I appreciate all the follows. That helps me out a lot, so thank you very much for that. Let's see. So this is our recursive function that renders all of our stuff. So I don't think the problem is going to be in here. It's probably going to be in the pass. This guy. So our locations are projection, view, model, diffuse map, and properties. So when we load up our locations, diffuse map, properties, model, why are we not? We didn't, yeah, I did strip the material stuff out of here. Are we just not getting the location at all? That would be very strange if that's what we're doing. So diffuse map is... Let's see where projection... So here we're loading all 5. Am I missing something? Are we doing this twice? Shader name. Did I accidentally set this up to do this twice? I might have. Internal data, locations. UI shader locations. Wait a minute. Is this left over from that other stuff that I removed? UI locations. Are we actually using that other locations anywhere? I don't believe we are. SUI shader name versus shader name. Shader name is standard UI. Why are we loading this twice? Did I have a merge conflict fail or something? Like, what is going on here? That could be part of the problem. Was that, oh, maybe this is left over from the old UI shader system. Okay. I'm going to get rid of this and this, because we don't need either. And I should be able to get rid of this. And we just use the standard UI shader. I don't think that's the issue, but that's certainly an issue. So we apply the globals, which is projection and view. Here's the bind local, apply local. But where are the instance levels things set? Here we go. So we set the property, set the diffuse map. Atlas. If we have an Atlas override, we use that. Otherwise, we use the SUI render data UI Atlas. For some reason, that is coming across as null. Which is interesting because, well, I see why it's coming across as null because it doesn't look like anything is actually using it. Did I accidentally nuke that somehow? I think I must have. Thor mentioned stream teams on stream. That's awesome. Yeah, stream teams are, they were really cool back in the day, but like, yeah, they're not as useful as they used to be, unfortunately. Vulkan is cool. Yes, Vulkan is pretty cool. I like it. Stretch Redeem, thank you for that. Oh, my bad, the other way around. Yeah, no, that's fine. It's all good. No worries. Yanking Glyph, thank you so much for the follow, by the way. That's why you had an influx of followers. Oh, I appreciate that. Yeah, I was wondering where that came from because I was like, whoa, there's a lot of followers. We also got rated by TCAP earlier, so I do appreciate that as well. And I'm usually not able to raid when Thor is on, unfortunately, just because it doesn't work out for me time-wise. But today, I was able to make a little bit of an exception. Okay, so our UI Atlas is null because we're never creating it. So that's neat. Let me look in here and see. I know there was a way in here to pull up file history. I think it was, I think I have to pull this up first. And then history, I think. Open file history. There we go. Uncommitted changes. I don't think I nuked it out of here, right? I think I just literally killed. That's, yeah, okay. So it was sometime before that. Descriptor factor, refactor complete. That's just local binding. Uniform location. What am I making? So I'm making a game engine from scratch using C and Vulkan. So let me just pull this down. So I'm making a game engine called Kohi. And so what we're doing is on video, started as a YouTube tutorial series. Now it's live streamed on Twitch. We are making a game engine that is built almost entirely on camera. There have been a couple things here and there that I've done off camera, but it's pretty sparse. But we're going through the process of building a game engine completely from scratch. So literally the first video of this series was us creating the GitHub repo and setting up our project, right? So we started from that point and we've been building on top of this as we go. So the engine itself is, I guess I already had it pulled up. It's 100% free and open source. So it's Apache 2.0 license, which basically says if you use the engine, all that I ask is that you just say you used it. That's it. And this will never be hidden behind any sort of paywall of any kind. There'll be no licensing fees, no royalties of any kind, none of that stuff. Any financial support or backing behind this is purely optional. And so thank you guys for the follow, by the way. I appreciate that. And so basically we're just we're building this as an educational resource so that folks that understand or that want to understand what goes into making a game engine can get an understanding of it. So remember that from like 2 years ago or so. I think I got recommended on YouTube while I was working from home. Yeah. So this has been underway for almost 3 years now, and I'm doing it in my spare time, right? So I'm not able to move that fast on it. I'm limited as to how much time I can actually work on it, right? And as Thor always says, use your 9 to 5 to fund your 5 to 9, right? So this is an example of that, right? Didn't know about the Twitch streams until I saw you in TCAP's chats. Yeah, so the Twitch streams are new. I've only been doing that about a year. So that is crazy. I have a bit of an idea on how coding a game works, but coding an engine is just out of this world. Yeah, so a lot of folks don't understand what goes into making a game engine and literally all the work that goes into that. And so that's why I put this together, right? Is to go through everything that is required to make one of those things from the ground up. So that it's a resource that's freely available out there for anybody that wants to learn from it or is just interested in kind of seeing how this stuff comes together, right? So yeah, it's meant to be an educational resource, and as such, I believe that education should be free, right? So that's why I'm doing all of this for free, right? There'll never be any of this that's paywalled in any way, shape, or form. Even on my YouTube channel, I don't paywall anything, right? Like, membership there is basically a token of support, and that's it, right? And that's just kind of how we roll. All right. So yeah, that's kind of the quick and dirty introduction there. So I'll also drop a quick link in chat to the website for any of you guys that want to check that out. All right. So I'm looking through diffs now to see where I went wrong, because I was pretty sure that even a couple minutes ago this was actually running. So I actually don't see anything here that I've done that should have actually stopped this from working. The only thing that we did was we basically just stopped using this, right? But that shouldn't have actually done it. Let me build everything real quick and try running it again just to make sure. Mr. Gainsworth, thank you for the follow. Appreciate that. Zealous Programming, thank you for the follow. Appreciate that as well. Is the code for making games going to be a custom language or one that already exists? So if you're talking like a scripting language, we're not going to do a scripting language, at least natively to the core of the engine, right? Our scripting language is going to be hot reloadable C. And so basically what that means is that whenever we compile our game logic library, that will be hot reloaded, and as the game is actually running for us to see changes. There are limitations with that, of course. And we've already accomplished that on the series. It's probably broken at the moment because the engine's broken due to what I'm working on. But the idea is that you can basically make changes to the game code on the fly as the game is running and actually have it reload. So we don't really need a scripting language, right? So we have ads. And so I will continue to answer the questions after we get back from the ad break, right? So once every 30 minutes, we are served with 90 seconds of ads on the Twitch side, right? And so the worst thing I think on a programming stream is to have to miss content, right, because of ads. So I like to pause the stream while ads are running. That way nobody misses anything. So we got about a little over 30 seconds, and then we'll jump back in. You got the exact same ad twice in a row. Nice. I love when that happens. It's funny. All right, got about 15 seconds, and then we'll be back. Hydrate some more, I guess. All right. I think ads are dead. We are back. All right, so let me see. Is the code for making games going to be a custom language or one that already exists? So I kind of answered this already, but the second part of that answer is we can also implement a scripting language as a plugin. So one of the concepts about this engine is I'm developing with it in mind that a lot of the systems are going to be plugin based. So what I mean by that is right now we have Vulkan as our primary rendering backend, but eventually we are going to support Metal. We're going to support Direct 3D as well, and that renderer is implemented as a plugin, right? So the application will be able to say, I want to use DirectX, or I want to use Metal, or I want to use Vulkan, and can use that plugin. Our UI system is actually implemented as a plugin. So if you don't want to use a UI system, you want to roll your own, you can just choose not to use it, right? Or you can choose to use it, either way. The audio system is the same way. So it's also implemented as a plugin, right? And so the idea behind that is that the application can choose what it wants to use, when it wants to use it, and when it doesn't want to use it. And you can even vary that between debug and release builds, for example. So if you want to use the standard UI system in your debug builds for like a drop-down console, but for release builds you don't want that, that's also something you can do. And so the idea of a scripting language could also be as a plugin. So that way it's not integrated in the core. All that logic and all that weight behind that isn't necessarily always included with every single game. So if you do want to use it, it's there. If you don't want to use it, you don't have to. So let's see. Are you doing plugin DLLs for different rendering APIs? If so, I'm pausing my hobby work and stealing some code when that's done. Yeah, that is exactly what I'm going to do. Right. So right now, the way it's set up is our Vulkan renderer is a DLL on its own, right, or an SO or whatever you want to call it, depending on platform, right. This is multi-platform, by the way. So Linux, Windows, and Mac. And so all of our Vulkan specific logic is within the Vulkan plugin, and then it interfaces with a renderer front end that's in the actual engine to actually interface with the rest of the engine. So we already have one of our first rendering plugins underway, and then obviously when we get ready to do Direct 3D and Metal, those will just be alongside of this guy, right? So that's the idea there. Let's see. Are you a brave enough dude to get data layout modifications working on hot reload? Eventually, that's the goal. It doesn't really do that right now, just because of the way that that works. Obviously, you recognize the issues there, right? And so that is a little bit tougher to do. It's an understatement, right? Because I've also been asked about switching rendering APIs on the fly as well, right? And again, that's another thing that technically is possible, but we're not doing it at the moment. So yeah, maybe in the future. Yep. Remember in the old days where we'd select DirectX or OpenGL from Half-Life? Yeah, exactly. So it's the same concept. Yep. I don't think I'm going to make an OpenGL plugin just because OpenGL, like, why at this point, right? If we're already using Vulkan, eventually Direct 3D and Metal for Mac OS, like, why? Why would we do that, right? Okay. So I suspect, I think our UI atlas was created by I think that was created externally and passed in, if I remember correctly. UI atlas, if I can spell. Let's see. So the standard UI system, when it goes to render, yeah, it feeds that data into the render data that gets passed on to the render graph pass. I wrote this code a while ago, so I'm having to refresh my memory a little bit on how it works, to be honest. So UI atlas is literally just a texture. I just need to find... where that is. So we have a texture map. Okay, that looks fine. That's during shutdown. I'm not worried about that. We pass it over on render, but this is just the setup of the texture map though. UI Atlas. Yeah, I mean, this whole engine right now is probably around 70,000 lines of code, so I can't exactly keep it all in my head at all times, unfortunately. So the standard UI state is what the owner is of that. So I'm wondering if there's something that's just not passing that through for some reason. I don't see... I guess I'm just going to have to debug it. So I think what I'll do is I'll try to see what the heck is going on there when we actually bind that, right? Mr. Gainsworth and Illusion Man, thank you for the follows. I appreciate that. Let's see. Did you choose strictly C just to get away from C++, or do you program C++ in your day job? I chose C because I like it a lot better. It's preference mostly, but also it compiles faster and it's a simpler language, right? So yeah, I chose it explicitly. Would you need metaprogramming to support data layout change and hot code reloading? Potentially. And that's the thing, is I want to research, because there's 1,000 different ways that you could approach it, right? And so trying to figure out how you would actually migrate that data layout from one format to another when you make a change, that would be the hard part, right? And is it really worth it, is the question. Sometimes it might be, sometimes maybe not, right? It might just be better to just shut down the thing and restart it, right? If your data layout changes. Because if you change your data format, you have to have a translation layer to go from the old to the new. And you're only going to need that during that one hot reload, right? So worth it? Maybe, maybe not. I suppose you could write that into your hot reloaded code. Like maybe that would be the way to do it. Okay. So let me launch this. See, this is the bizarre part, right? This is the UI system running right now, and it works. Even if I launch like our little console here, right? This thing works, right? But when I load up a scene, that's when it stops working, which is what's really bizarre. So I'm not thinking it's actually the UI system at all now, the more I think about it. So if I look up my console.log, ultimately what's causing it to crash is this, but I think that might be fallout from something else. See, we're getting a void VK sampler, but I have a feeling that like something I'm doing is just clobbering memory of the next thing in line. Because we don't have anything to sort of check boundaries on that yet. So I am still kind of thinking that what we're dealing with is more fallout from these two guys. Let me see. Because there's nothing in here that's changed or has really gone wrong. So that means it's Oh wait, you know what? It could be. Let me look into the... That's going to wind up being the scene pass, potentially. Maybe the scene pass is doing something it shouldn't be. In fact, I already see something here that's wrong. So we have texture map resources for multiple shadow maps when there should only be one. One per cascade. That is not. Should just be shadow map, right? And we should technically have one per frame. So that is wrong. Which means that's wrong. I think we might have actually just found what it is. Yeah, I think that might be the problem. Wait a minute, that shouldn't be... Where is that resource? Where is that coming from? So the shadow map source. Is figured out during our render graph linking. Texture map, shadow maps, I. So we do need... We do need multiples of these. But not per shadow map, per frame. So I guess, okay, so this is correct. But what I had down there was wrong. So per frame we have here, if we're triple buffering, that'll be 3. If we're double buffering, that'll be 2. We go ahead and we get, we create a new shadow map, texture map rather. We set up the texture from that index. So, shadow maps. Okay, so that's times frame count. That should be correct. So actually, maybe that was correct. This should be... That should only be destroying that, though. So that outer loop was actually wrong. I doubt this is going to be the fix, but it might be. Part of it, anyway. Oh, here's another thing that we missed. Potentially, the material system apply local. Binds local, sets, and applies. Okay, that... Don't we need to know what cascade index it is, though? Let me see something. So... PBR, the PBR shader, how do we know which index we're dealing with here? Have we passed that in yet? I don't think we have. Cascade splits. So that may be a problem we have to address too. I don't think we're taking that into account. Max instances 5. Okay, that should be fine. Because this is getting cascade index from where? Right. We're generating it. Okay. I thought we were passing that in for some reason. Okay, so we should be fine as far as this is concerned. We apply the instance here. We apply the globals, which I think the globals aren't any different for this than any other material. Okay, so that's the PBR, the static geometries. Let's look at the terrain portion of this. Is it on the other side? Is it first? I think it might be first. That's this guy. Apply instance. Yeah, so here's our terrains. Use by ID, terrain. Okay, so it's using the correct shader. It's applying the globals. For each terrain, it's applying the instance. And then applying the locals and then drawing it. So I don't see anything here that's out of whack either. Nice music. Yeah, this music is actually from Heartbound, which is Thor was thankfully nice enough to oh yeah, there you go, music. Thank you for that, Ruche. Yeah, so that is from the Heartbound OST, which Thor was nice enough to let me use on stream, which is awesome. EA Seed's Halicon presentation had some info specifically for implementing rendering backends and shared libs. Yeah, so that's exactly what I've done with Vulkan. And I think I've seen that presentation before, but it's also been a couple years, I believe, if it's the one I'm thinking of. Let's see, over on the YouTube side, I need to catch up with chat over here. Some issues with data layout can be addressed with X macros. Some issues, yes. Sister Grimace, thank you so much for the Supporter 3 over on YouTube. I appreciate that very much. Thank you. Been watching for a while. All the best in the new year. I appreciate that a lot. Thank you very much for the support. All right. So I will say, this is the side of game development that a lot of people don't show. It's when you run into stupid issues like this and you have to troubleshoot it, right? And this is several layers of stuff deep, right? So sometimes it can get a little bit complex. And so I don't mind showing when I'm struggling with something. It happens. I think it's I think it can be valuable, right? Just to see the way that somebody else looks at a problem sometimes can be useful, I think. Let's see. So this is complaining specifically about the terrain version of this. Instance frame 2. And it's interesting to me that it only happens in the terrain and not the PBR version of that. Actually, maybe that might not be true. Let me turn off terrains real quick. So I'll open up my scene file. And let me try turning off the terrain. And see if the PBR shader does the same thing, because that would be a lot easier to fix the issue there first and then move with the fix over to the terrain side. All right, so let me load this up. Yeah, okay, see, we're getting all kinds of validation errors now. So, the terrain thing, I guess, was kind of blocking us, right? So we've got some other stuff to figure out. Object image view. This is all skybox view stuff. Okay. So I suspect this is the fallout from the same issue. Yep. So it's basically saying in our binding 1 and 2, the first image is a cube map, is being bound there. So if I go to render doc, and let's get a new capture. I want to see that the shadow map thing was actually solved first. All right, so if we look at, oh, it looks like we got capture has 70 issues. Yeah, that's probably because of the binding issues, I'm guessing. Yeah. Okay, so we're partially fixed, right? Because now we have the normal map showing up here and the correct material textures except for the first index, which is actually what's throwing everything off. So something is binding the skybox as the first material texture instead of the last. Oh, look at this too. This is actually wrong as well. Shadow texture equals skybox, that's also wrong. Why is the skybox being shoved like everywhere? That's very bizarre. Okay, so yeah, like all of our materials are correct towards the front except for the first one. And then it's like getting clobbered back here too. So I guess let me look at what our PBR shader is doing. So our sampler indexes are all correct. So these are the indices for this guy. This just has 1 and this just has 1. But for some reason, what's being bound, or what should be bound here, is being bound here and here. So that's definitely strange. Let's look at I don't think it's the shader config. PBR. Nope, that's set up the same way, so that should be fine. So I'm beginning to think like maybe it's our shader system. Let me put a debug point in. In our shader system. Let's see. So when we're adding a sampler, I guess is where we could look at that. And it seems to be instance specific. So let's do this. Location. All right. So the shader that we're looking at right now is the built-in skybox. I'm going to skip that one. Okay, this is shadow map. I'm going to skip that one too. PBR material. Okay. So our location for that one should be 0. Okay, and then if we add to that location, uniform counts is 12. It is a sampler. Our index is uniform count. That makes sense. The type and the scope should be copied over properly. The array length is 5. which I think is correct, right? That's our material texture. So yeah, it is an array of those, so that makes sense. It's a sampler, so we use the location itself as the location instead of the index. Samplers have no size, so we don't have to worry about that. Set it in the hash table. And then return. Okay, so let's go into the next one and make sure that it increments all that stuff correctly. Internal sampler add. Okay, so this one should be location 1. Increments that. Internal uniform add. Index 13. The location should be 1. Yep, okay. Okay, so all of this looks correct. I don't think this is the issue. So it must be... It must be where we translate that when we acquire instance resources. So let's see, the shader in this case is PBR material, okay. So we just grab a material ID. All right, so the uniform sampler count is 3, which makes sense because that's 1 per configuration. Okay, that makes sense. We loop through each one of these. We get a uniform. We say this one is... This is our first one, our materials, right? So we have an array length of 5. Okay, that works. So our uniform texture maps should be an array length of 5. Should be 5 texture map pointers. And then we should have a descriptor or descriptor states for each one of those things. Copy over the texture maps. Which are just default maps for now. That makes sense. We set the generation and IDs to 0 for each frame. This works as I would expect it to. All right, and we have ads. So I'm just going to break here for a second. So anytime we have ads, I just like to break the stream just so that nobody misses any content, right? I know that the YouTube side doesn't get served ads quite like Twitch does, but Twitch, we get them every 30 minutes for 90 seconds. So let's see, over on the YouTube side, Riley Hawksworth, I really like what you're doing. Vulkan is hard to learn. Yeah, true, but I appreciate that. Thank you. Currently learning to make a software renderer in C++, but not really using the C++ standard library. It is Windows only. Nice. That sounds like a pretty fun project. Let me see something real quick. All right. So ads are almost dead. I think we've got another 10 seconds, right? Let me see something real quick. All right, ads are dead, but for some reason, I just got a notification that my hard drive on my machine is like almost full. My C drive is like almost full for some reason. And I'm trying to figure out why before it gets full and then stuff breaks. So just bear with me for 1 second here while I figure this out. I don't know what's filling it up because I'm not even recording to like my C drive. So that's kind of bizarre. It's probably... I think I know what I can move at least immediately. Let's see. Well, maybe not. Oh, here we go. I can get a couple gigs out of this. I just don't want my my drive to be completely full and then like kill the stream, right? That would be bad. So I can at least kill like a couple of old recordings that I don't necessarily need anymore. Then I'll have to fill some space later, or free some space later. Copernicus, thank you for the follow. I appreciate that. Welcome. I'm just freeing some hard drive space real quick because Windows is bleating at me. All right. That should work for now. Maybe. Okay. Let's see. Yeah, Saturday on a midday. What a surprise. Yeah, exactly. Don't make a software renderer. It is not ready. It is not for any use. I disagree with that. So, the purpose of a software renderer would be to really understand about what the renderer is doing under the hood, right? What the GPU is doing for you under the hood. It's fantastic as a learning exercise. Would you want to use it in production? Probably not. But I think there is value to doing that, right? Hey there, following Kohi since a while. Did not know you were streaming on it. Happy to follow. Awesome. Yeah, I have been streaming on Twitch now for about a year. Yeah, we kind of converted this to a stream about a year ago. So yeah, that's what we're doing now. All right. So let me see where exactly. So we're uniform buffer. I have a feeling we're probably just not setting descriptors properly. So our acquisition looks like it's correct. So I'm wondering if the application of that is correct. Because we allocate our descriptor sets, that seems fine. So shader instance resources acquire. I think this is probably where we need to look. Or not acquire, rather. Where we apply it, I should say. So apply instance. So this is where we make the translation between our uniforms and our data, and we copy that over to the GPU. So our uniform buffer's working as expected, I think. That's descriptor 0. And here's where we iterate our samplers. So let me put a breakpoint here and continue to that. And I'm just going to continue. Actually, I'm going to let it run for a second. And then I will load this and hit a breakpoint. So this is the skybox. I can skip that. The shadow map. Let's see. Probably I'm going to have to set a breakpoint a little bit higher than this. So if we do scene pass, and then execute. And go to, let's see, that's terrain. Apply instance. This is where I need that. Okay. Then I can step into this guy. PBR. So we set our properties. And then our individual maps. So we set by location arrayed. I'm wondering if this is maybe what's not working correctly. So we make sure that we're on the correct bound scope, which should be local by this point. Yep, or instance rather. Step into the back end, and it is a sampler. And so we get the instance state, the bound instance ID is 1. And then instance uniform sampler count, we have 3. And so we basically set all of those things. So the uniform location is 0. The array index we're setting is also 0. And the map we're setting here is a 2D texture, which is what I expect. What's odd is, where is this getting clobbered by the skybox? So I'm going to set a breakpoint here. Uniform location. Okay, so we set the uniform texture maps at the array index, which in this case is 0 to the map. Okay. So that looks like it works, at least if it's past the right data, that should work. All right, and so we can step through this, step over this, honestly. Let me get rid of some of these other breakpoints. We can step over these ones, because I know our material textures here are good. And then our shadow map. PBR location, shadow textures, right? So that's location 13. Oh, which makes sense. Okay, this is location 12, 13. This should be 14. Okay. And then our sample shadow map is index 5, which is correct. This one is index 6. Okay, so that seems fine. So we set by location arrayed, which is 0. Okay, uniform is set index 1, size 0, that makes sense. Offset 0, location 1. Location 1. So the uniform itself is a 2D array. For the shadow map? Why is that a sampler 2D array? Oh, yes, it is. It is an array, right. That's correct. Okay. So we go into the back end. Sampler try set. Uniform location should still be is 1. Array index is 0. The map that's being set is 2D texture array. Let me check. Ask uniforms, and I'll do, I guess, as an array of 20. I just want to take a quick look at this just to make sure that what we're looking at is correct here. So 12, 13, and 14, these are our samplers. All right, so location 0, 13 has location 1, and 14 should have location 2. So that location is basically the index of the sampler, right? So that looks correct to me. Array length is 1, should be 1 for each one of these, except for the first one, which is 5 different textures. Okay, so that is fine. Okay, so let's try and set that. Okay, so the uniform texture maps sub-0 is going to be set to the map that's passed in. Just 2D array. Okay, that makes sense. And the last one should be largely the same thing. Right, we know it's a sampler. We'll try and set this. Sampler count is 3, right? Uniform location is 2, array index is 0. The map is a cube texture, which is actually what we expect. That's what should be there. Okay, so we've set that. We apply the direction on point lights. That stuff hasn't changed in forever. I know that's fine. Set by location, numpy lights. Yeah, that should be fine as well. That's location 18. Okay. Apply instance. This is what actually creates the descriptor rights. So maybe we're wrong in here. Let me just take a quick second and check on chat. Let's see. Are we sure sampler 2D array does not take up several consecutive binding slots? It should not at this point. I'm pretty sure that is not doing that. What I'm more concerned about is actually the sampler 2D array. Right, like array written out might be doing that. Do you have good references to give to Vulkan or not? Developing my own render engine using Vulkan and Metal as I develop on Mac. Still have some troubles to develop efficiently some features. A lot of books exist, but do not really seem good, so maybe interesting blog posts for advanced techniques. There is some stuff out there. You'll want to look at some of Arseny Kapulkin's work. What the heck is his website? I think it's... what was that? I can't remember. It was like some weird spelling of Zeus, I think. Zeus.io, I think it was. You know, I'll just look for his name. Yeah. This website right here. I'll paste it on both sides. Yeah, so that's a pretty good resource for some Vulkan stuff. That's in there as well. Oh, thank you. Delicious. My wife is the best, y'all. She just brought me a nice hot beverage. Let's see. If you're looking for Vulkan specific examples, Sasha Williams' repo has more advanced examples. That's another great place I was about to recommend. Yeah. There's not really too much in terms of a blog post, like explaining a lot of it. He has some posts on his website, but that's another example for sure. Many of the recent rendering talks at GDC and deals and such deals with modern API usage. Look at some stuff on GPU Open and AMD and the NVIDIA equivalents. Yeah, I would agree with that. There's lots of stuff out there, right? Already took a look at ARM samples actually, but I don't get what the automatisms of Vulkan as I got using Metal even after a year almost of developing with it. Yeah, Metal's a fully different beast altogether for sure. Zooks. Yeah, it was Zooks. It was like this weird spelling of Zeus is what I always think of. Sampler 2D array only occupies one slot. Correct. But I'm wondering if maybe it's doing more than that. Not necessarily in shader memory, but like in our actual resources, right? Stefano, thank you so much for the follow. Appreciate that. Yeah, with .z being an indexity, right? Yeah, exactly. Fireplant Games. This song is familiar. What is it again? I hope that's... So this one is Extra Avocado. The one before that was Baron's Parade from the Heartbound soundtrack. Cool. All right. Google suggests sampler 2D n occupies n locations. Yeah, so our concept of a location here is a little bit different. Because we are keeping metadata for all of our uniforms and samplers in the actual shader system itself. And so our concept of what a location is might not necessarily 100% line up with the way that Vulkan does it, because it's meant to be renderer agnostic, right? So I have to translate from that one layer to another. And I think that's basically, I've gotten that wrong somewhere. Note that location and binding is not the same thing, 100%, yeah. I only do OpenGL and not the most modern versions. Yeah, exactly. Yeah, so you have a descriptor set, and then you have descriptor binding, and then within that binding you have descriptors. And it could be one or more descriptors. So yeah, it's not exactly the same thing, you're correct. Okay, so basically what I'm going to do is look through these descriptor rights and see if any of these are wrong, because we have the first right is our uniform buffer, which is just our UBO object, right? That big contiguous block of memory that contains all of our standard variables. And then after that, we have our samplers, which is this guy here. So let me continue to here, right? And our samplers work a little bit different. So we have 3 of these, and these line up with these guys here, right? So this is considered one sampler as far as our code is concerned. This is considered another sampler, right? And then this is our third sampler, right? Even though this is an array of samplers, that array is treated as part of this whole entry, right? This uniform entry. And so basically what this is a sampler 2D with 5 descriptors in it, versus this is just one descriptor, and this is just one descriptor. And so that is kind of what I'm debugging now to make sure that that's actually right. So this has global, just determines what our descriptor set index should be, because we have the possibility that maybe a shader doesn't have any global uniforms, it doesn't have any global samplers, and so we wouldn't need that first descriptor set, so we could actually clobber that and then use index 0 instead of index 1, right? So that's what that's figuring out. And then we go ahead and we grab the descriptor set config for the internal, for figuring this out, right? So we go ahead and grab that. And if we take a look at that, our binding count is 4. Wait. Descriptor type uniform buffer. But we already did that. I think I might have found the problem. So let me think about this for a second. So we would have done descriptor 0 uniform buffer is this guy, right? We would have done that first. Instance uniform sampler count, but we're starting at 0. Sampler uniforms in here. So this contains all bindings for that, but I think we're 0 indexing this and we shouldn't be. I think that might be the problem. Sampler uniform. Oh wait, maybe not though, because we're not actually explicitly going by descriptor sets here. Bindings, binding index. No, we're good, actually. Okay, so we iterate each sampler binding, right, which there's 3 samplers. And we separated the sampler bindings from the actual, from this guy, from the total bindings, right? So I think we're good, because the binding index starts at 1. Because we've already bound this up here, right? So we keep track of that. We say if we have uniform buffer data, we start at binding index 0, and then we increment that here if we had that data, which we did. So now we should be effectively at index 1 if we're using the binding index. So let me skip over this. So our descriptor count is 5, which does line up with this over here, which makes sense. So the image infos, we basically have to fill out this array of image infos, right? And this shader max instance textures is basically the max number of textures we can have bound at once per instance. So we basically fill this out as far as we can go. I suppose I should probably 0 that memory, but it doesn't really matter because we could provide a count. So we loop through our binding descriptor count and our uniform texture maps. So let me actually do this times 5. So here are our 5 texture maps. 2D, 2D. Yeah, so these are all, I think these are all correct. Okay. So those are correct. So we get the map, we get the texture, we check to make sure that we actually have a valid texture. We use a default if we don't. In this case, we do get the default. Map generation is set to invalid because we're using a default texture. And then we set the image data in image infos sub D, which in this case is the first one, to the image view. Context samplers. So I think that's correct. Let's see. Random question, what's the white object behind me? Let's see. Let me look on the... Are you talking about... Are you talking about this? The other behind, like that right there? Is that what you mean? That's the only thing I can think of. Hang on one second, guys. Yeah, I'm not sure if it's that or the lamp. Yeah. If it's that, that's a photo frame. Yeah. Or if it's that, it's a lamp. So I'm not sure which one you mean. Let's see. Are we commingling? Co-mingling? I think that's what you're saying. UBO and sampler bindings. I think those come from separate pools. No, they come from the same pool. The pool has two different sizes. So, no, I don't think it's that. Yeah. Yeah, so that's a lamp right there. In fact, Alexa, office on. Okay. Yeah, so that's just a lamp back there. I just didn't have it on. It's normally on because I stream at night, but yeah. Okay. Given that you operate at a much higher level than me, it's damn good to see you fighting bugs as well. Yeah, I mean, we all fight bugs at different levels, right? And sometimes the bugs that I fight are at stupid levels, and then I find them later on, and I'm annoyed how stupid it is. But yeah. Okay. So now that Thor's Hype Train song is done. It's about time for ads actually here in a minute, so we are going to be pausing here in a few seconds for ads, I think. Let me go back to the other view. I think that's the right one now. Yeah, okay. My OBS also decided to ball itself up in the corner for some reason. All right. Okay, let's see. In OpenGL, I'm pretty sure you can bind a UBO to index 0 and a texture to index 0 and be fine. Yeah, because of the way that OpenGL works with those things, like it has separate slots. It uses sort of slots for textures, which is kind of what we're doing as well. It's pretty similar to what we're doing. In fact, that's actually kind of where I got the idea from. But we have ads. So yeah, we just like to pause the stream every once in a while whenever ads come up, right? That way, nobody misses any content. So we got about 50 seconds left on ads, right? So, man, I'm really hoping to be able to solve this today. But we're actually technically working on something different than we were working on yesterday, so that's good. We're making progress anyway. Got about 15 seconds left, and then we can continue. By the way, I just want to say thanks to you guys for being so interactive today. That's pretty awesome. I like chatting with you guys and talking over stuff with you guys. So thank you for being so active. I do really appreciate it. All right, so ads are dead. And we can jump back in. So basically, it looks like I'm thinking this is actually working the way that we want it to, right? Because our binding index seems to be doing what it's supposed to be doing. We build out this image infos array, right, which seems to also be doing the correct thing. So when we go to write the descriptor set, we have the instance descriptor set, which we grabbed up top. The destination binding is 1, right? So this is our material textures. Our update sampler count is 5, and our image infos are here. And as we can see in the first 5 of these, we actually have proper bindings. So as far as I can see, at this point, it looks correct. I don't see anything here that seems wrong. So we basically put that into descriptor rights. Descriptor right count. Hold on a second. Is this... Didn't we have that up here as well? We have a descriptor right up here. I'm pretty sure we did this. Why do we not have one down here? Why is that still 0? Descriptor right count is 0. And I'm pretty sure instance uniform count is 4. Why did that not get bumped up? Let's see. So the generation... Oh, okay, I'm gonna have to do it this way, I guess. Is 1. Okay, so that's already been updated in the process. So I guess we didn't write that one this time because it's already been written before. Okay, I guess that makes sense. Okay, so we add to our descriptor rights. Descriptor right count ++, binding index ++. We switch to the next binding state. Binding descriptor count is just 1, which makes sense because we have that one singular sampler 2D array. So that looks correct. Adelphos, thank you for the follow. Appreciate that. Welcome. So we go through this. Fill out an image view for it. And then a separate write for that. Right? Okay, so that looks fine. So this is destination binding 1 with 5. Destination binding 2 with 1. And then the last one, we should also have 1. We do. Our binding index is 3. So this should be our cube map, right? Yep, it's our cube map. Okay. And so we use that to create an image, update the sampler count, create a write, add that in there. And yeah, that looks correct. And then we do the descriptor write count is above 0. So we passed it. So that looks correct to me. So let's see. Are we binding the correct one, I guess, is the next thing. So the first set... Determine if... I wonder if I got this wrong. We do have globals, though. So the first set should be set 1, which is the instance set. We're binding one set. That looks correct to me. So I don't think that's where the issue is either. More of arguing with Vulkan? Yeah. It's slapping me around a bit at the moment, for sure. Doesn't need to be offset since the image writes are common, or do we call write descriptors inside the loop itself? So no, it basically creates, it does the update descriptor sets outside of that, right? So in our last case, we created 3 descriptor writes. So 1 for each one of these bindings. 1 for this guy, 1 for this guy, 1 for this guy. Or the image info is common for all the descriptor writes. Oh. Shoot. I see what you're saying. I think you're onto something. I think you might be onto something. So for each... wait a minute. No. It's per sampler. Although... image infos. That technically... that would go out of scope before we actually apply those writes. Why is that not erroring, actually? Because every time we loop through this, we're recreating this, right? And we're assigning that here, right? So we finish this loop, and we use it here, and we build up all this stuff. But like this image info goes out of scope. Yeah, I think you might be onto something there. Dum. I need to probably dynamically allocate those and then free them when I'm done, which kind of sucks. That kind of sucks, but do I have... because it's technically the same, it's going to be the same problem for the instance as well. So what I really should do here is, I think I need a new one of these every time, but it needs to be dynamically allocated because this is going to go out of scope, and then that's going to be a problem, right? And I think somehow it's managing to just reuse this memory. I'll bet that's what's happening. I'll bet that's what it is. Sleepy Rhino and Fear of Code, thank you so much for the follow. I appreciate it. Welcome. Okay. How was this never an issue before? Because this existed in some form since the very beginning, and I guess we just never hit something that actually used it, right? If we at least call VK update descriptor sets in the same function, if not in the same scope, just lift image infos to the function scope. Yeah, I could do that, but the problem is this image infos needs to be filled out differently per one of these guys, right? And I want to, it's much more efficient to pass all the update descriptor sets at once instead of just calling them individually. It'd be much better to just fill them all out and throw them all over to the GPU at once. So hoisting that really isn't going to work, right? I really should just dynamically allocate this thing, and we can do that based off of this. And then what I can do is I can pull in the frame data into this function so that I have my frame allocator, which is a linear allocator, which is much faster for dynamic allocations. And then I won't have to worry about it. Make it a large array. I could do that, but then the problem is... Let me think about that for a second. Because if I were to do that... I could offset this by that, right? I could just, like, move the pointer forward. That seems kind of gross, though. But it might be faster. The only problem is if I have something that really takes a lot of... Like, technically, I'd have to create a really large array for that. A really large array. I think I'm overthinking this, quite frankly. So, what I might do instead... Image infos. What I'm going to do is do this. So it's going to be the size of VK descriptor image info times binding descriptor count. And then memory tag array. And then I'll just go through and clean each one of those up. I guess that seems kind of poopy too, to be completely honest. No, I need to do this the right way. All right, so what I really should be doing is doing apply instance. Shader needs updates. I guess we'll tack it onto the end here. Frame data. Right, because we have a frame allocator that's a linear allocator that we should be using for stuff like this. Because the linear allocator is really fast, right? It just moves a pointer and gives us memory. So if we do that, and then we go to let's see, apply. Is that apply instance? Yeah, apply instance. We should probably do it to both of these, actually. So we could say struct frame data, p frame data. And I guess we should probably also do it to apply local while we're in here. It's kind of a sucky interface change to have to make, but a necessary one. So we'll do the same thing here. Same, oops. Oh wow, it kept the, okay. Frame data, p frame data. And then we'll make that same modification to render types, which is our interface. So apply instance is going to be frame data. Apply globals. So right here. Oops. In one. In another one, I guess. There we go. And apply local. It's right here at the bottom. Move that up so you guys can see it. Struct frame data. P frame data. Front end. I'll have to make this interface change in a few places, but it's going to be worth it, I think. So apply global frame data, P frame data. Let's see, apply local. We probably should have done it this way to begin with, to be honest. So that's apply globals and apply instance. Needs that as well. Apply it here as well. So, whoops. Frame data, P frame data. And then P frame data, pass that through. Pass that through. Wait, where did my... Apply local. Yeah, here we go. Frame data, P frame data. Pass that through. All right. Because our P frame data basically has an allocator with it, right? That's all of our sort of frame data that we need to pass and use around. It's got like our timings and other stuff, and we probably should have that in here anyway. Let's see. Can you reset that memory arena every frame? Just let that clean it up. So that's essentially what my frame data's allocator does. Like it's got a it's a linear allocator that just has a block of memory, and every frame that just gets reused. And I don't even bother clearing it out. I just reallocate it for different stuff, just override it. Or locals just push constants, or using push descriptors as well. They're push constants. If this is memory that is strictly speaking only needed locally in a function, a global API change up through the Vulkan layer might not be the best. So, yes and no. It's probably something we should have in there in case we need it anyways, because this is something that's done per frame. So really, most things that are done per frame should have access to the frame data and thus the frame allocator. New Gen K, what's going on? Good to see you here. It's going pretty good. How about you? Did you have a stream today? New Jank, by the way, is working on a pretty kick-ass looking retro game, by the way. So highly recommend you check his channel out. I'll do a shout out actually. If I can spell correctly. There we go. Awesome. Person of Internet 1 and John Bertotti, thank you so much for the follow. Appreciate that. And welcome. All right. Man, programming on your own project is relaxing and soothing. Workout relief stress. Sometimes causes more stress. Yes, absolutely. Absolutely. Yeah, no problem, man. It's a really neat looking project that you've got going on so far. So I definitely like the look of it so far. All right. So let me go back and make the change that I was thinking about making, and then implement this everywhere else. So we're gonna need to make this in our apply globals and our apply local. So I'll do local first since that's where the problem is. Instance rather, not local. So I knew I recognized your name, by the way. I've been subbed to your YouTube for a while now. Oh, awesome. Thank you for that. I appreciate it. Yeah, actually the YouTube channel, speaking of that, I hit a pretty sweet goal. I was hoping to hit, Windows. I was hoping to hit 12,000 by the end of the year, and we just made that, which is really freaking cool. So I appreciate all you guys. You guys rock. You guys are awesome. Really appreciate that. I was hoping to hit that by the end of the year, and you guys made it happen. So thank you for that. All right. Why is this bleating? Let me get rid of this guy for a second. Was this... Okay, that just forward declared it, so front end. It's core frame data. Okay, that's what I thought. All right, so we need... include core frame data. All right, so what we can do now is, instead of just a straight up allocation, which feels kind of lame, we can use our frame data allocator allocate. Right, and I think that actually does not want the memory tag. And what that means is that we don't have to worry about cleaning it up afterwards. We could just allocate it here, and then since that frame data allocator gets reset, the pointer on that gets reset every frame, I don't have to worry about going back and cleaning this up and freeing and all that crap, right? Because that sucks. So now I can just have this, the size that it needs to be, and we're fine. We don't have to worry about it any further, right? So we could just set that, and actually that might, in and of itself, potentially fix the problem. So I'm going to build this, because I know there's some interface points I'm going to have to change. Yep. Because there's places where I'm calling like apply instance where it's just not doing what it should be. So shader system. Let's do the H file first. Let's get rid of that. So let's see, apply global, apply instance. Those are going to need to be, do we have frame data in here yet? I don't know that we do. I don't think so. So let's just forward declare that, I guess. Let's put that, I guess I can put it here. All right, and then in apply, let's do global first. We need frame data. Have to say struct frame data pointer p frame data, and then well, okay, struct frame data p frame data. Right, and applied local is now, instead of going to be void I feel like we should be passing a shader with that as well, but I guess it's the currently bound shader. So this one we're just going to have struct frame data, p frame data, right? Shader system. So at this point, it's really just a pass through. Frame data, p frame data. Whoops. P frame data, if I can type. And then we just pass that through here. And then up here is going to be the same thing. So frame data, p frame data. And then here we just pass p frame data. Do the same thing here and here. Which means our uniform or our material system is going to also need this. But it's something we probably should have put in place anyway, right? So, and actually, oh, look at that. Our material system already has it, right? So that's actually really good. Let's do global first. Shader system, apply global. This is going to take in p frame data. Do I have that defined as a const here? I guess I did. I thought I got rid of that everywhere. Right. Applied local doesn't have it, so that's going to wind up being frame data, p frame data, and then we pass that through here. Yeah, I know it's conflicting. That's fine. Let's go to the H file and just fix it here real quick. So apply local is going to have struct frame data, p frame data. Apply instance here did not have const, just global did apparently. Okay. Shader system apply local. Struct p frame data. Oh, this should be p frame data, not frame data. This is going to be needs update and p frame data. Sorry, I've missed a bit. So what was the issue? Yeah, we're still kind of working on the same thing, but I will get back to that when we are done with ads. We have ads. And so I'm going to keep just kind of propagating this change up, because this doesn't really matter if you guys miss kind of some of this, right? So all of our passes basically are going to need that. Right, so this is going to be p frame data. Oh, that's for bind. That's not what I need. I need apply. Got about 20 seconds left on ads, and then we'll kind of talk about what the issue that I found was. adds are almost done. Okay. Let me just put a couple of these frame datas in here because we need to pass those through. This is something I probably should have done a while ago, honestly. All right, so what we were doing was this image infos array that we had here was locally created in this loop, right? And then at the end of that, we kind of filled out these image infos and set up this descriptor write. But that descriptor write wasn't then used until outside the scope of that. So I think what was happening was somehow the compiler was basically using the same block of memory over and over for this again, and it was just referencing the same thing over and over again and clobbering stuff. So I think that might have been the issue, because technically this goes out of scope, right? So now what we're doing is we're dynamically allocating this so that that's not an issue. But we're using our frame data's frame allocator to do that, because this is different from our normal allocator in the sense that it's a linear allocator. So it's already got a block of memory allocated. And when you say, I want some memory from it, all it does is just move that pointer along a linear path of memory, right? And just gives you that to you. So there's no free list, there's no freeing from it. It's literally just a pointer move, and then it returns memory. So it's super, super fast to get memory that way. And so what that also means is this allocator is essentially reused on every frame. So we also don't have to worry about leaking memory or cleaning this up, because it winds up getting reset. That pointer gets reset, and we just overwrite that memory every frame. And so what we wind up with is the ability to dynamically allocate in place like this, not have to clean it up, and not worry about it having to go out of, going out of scope. We could have hoisted this up to like further up here in scope, but if we did that, then we'd have to maintain offsets. And then when we were creating all these things, we would have had to maintain offsets into that, which would be relatively fast, but still not ideal, right? So, Redemption, thank you so much for the follow. Appreciate that. All right, so now what I'm doing is I'm basically going through and everywhere that was calling this apply instance or apply global or apply local, we now have to pass this frame data. But most of the places further up in code already have access to this, right? So I'm just literally going through the code base now and adding all of those missing frame data arguments, right? So looks like our passes are going to be the main spot that we have to do. But our passes do this, right? And our passes already have an execute frame data, right? So we already have that there. And so we should have been doing this a while ago, and I just never thought to actually do it. So we do apply global, p frame data. When we do apply local, it's p frame data. And then if we do apply instance, which I think is down here, we add p frame data, right? And we just basically just pass that through to all three of these. That way we have it, right? That's what the interface probably should have been. But when these things were initially created, p frame data didn't exist. So there's that too. All right, the editor pass is next. Editor pass. So apply local. And apply global. And was that it? I feel like I missed one. Scene pass and material system. Apply local, so we need p frame data. Okay, I think that's it. And then material system. I thought we got all these actually. Maybe we did. Scene pass, line 331. I thought I got all these. Nope. Shader system set by location. That may need to have bindings set, but we'll see. Skybox pass. Alright, so p-frame data. So basically just plugging this in wherever it's missing, right? Nothing too exciting at the moment, unfortunately. Did I change my stream schedule? No. So I normally stream around, my official schedule is 9 p.m. Eastern Standard Time, Wednesday night and Thursday nights. But I decided to do an extra stream today, just to kind of knock some stuff out. Sometimes I'll start the stream a little bit early during the week. Sometimes I'll go a little bit over. I did especially this week because I had some time off, but render view pick O. I really need to convert these two. These are deprecated views that aren't technically used, but I'm keeping them here because I need their logic. For making them into proper passes later on. Jeez. Okay. Let's see. Yeah, using an object outside of its scope. Yeah, sanitizer is definitely something I need to hook up. I played around with it a little bit, but trying to get one working cross-platform is a little bit tricky. You found some bugs like that and in the past and opened up an issue? Yeah, I think I know which issue you're talking about too. I actually need to do a bug scrub on that. Wireframe. C file. So we'll have to see if I can ever find all the places here. Okay, all right. So that's built successfully now. So let me you know what? I'm gonna try running. Yeah, let me try running this real quick. Let's see. Let's get rid of. I might have to get rid of the breakpoints that I have because a lot of them are going to be invalid now. Okay. What do you know? That seems to have fixed it. All right. So that's cool. Obviously we've got some performance issues to fix, but it looks like it's even rendering our shadow map correctly. So let me turn terrains back on. Oops, wrong editor. All right, so let me just open this back up. All right, and load. There it is. All right, so our shadow maps are working again. Woohoo! Finally got it working. Only took about 10 times longer than I thought it was going to. Now, obviously, there are some performance implications that we're going to have to think about here. And that's probably going to be the next pass that we're going to have to start thinking about pretty much right away. Because obviously our performance is not acceptable at the moment, right? We're averaging like 25 frames a second. I've got a pretty beefy graphics card, right? So, you know, this pass is completely unoptimized. We need to perform some culling for the shadow maps objects, because we're not currently doing that, and start looking into some additional methods of performance. But for those of you who have not seen the engine yet, this is it so far. So we just recently put in a PBR rendering pipeline and shadow maps. And we have cascading shadow maps, which is why we have multiples of them. And currently we're using 2K shadow maps, right? And so we've got a little bit of image-based lighting in there to get our sort of ambient correct. And if we take a look at the debug lighting modes, right, we can really see that those shadow maps are working pretty nicely as intended, right? So we have a few different rendering modes here. We have that. We have this one that shows the normals, and then we have this one that shows the cascading of the shadow maps, right? And so as we move outside, we can see basically what cascade we're using for the shadow map, right? Like, so red is the closest one, right, and the highest detail one, versus green is one out, and then we have blue, and then we have yellow. Then of course, if we switch back to this, we have our normal, right? So yeah, actually accomplished everything I wanted to accomplish on this stream, which is freaking sweet, right? Video on optimizing should be interesting and popular. Yeah, we need to heavily optimize this, right? Because so part of the thing about the way that I program is, and I know a lot of people complain about this, right? But it makes sense to me when you stop and think about it. I program things to get the thing to work first, because I don't care how optimized your code is. I don't care how clean your code is. If it doesn't work, it's useless, right? So the very first thing that I always do is I get it working, and that's with whatever hacks in place are necessary to just get it up and running, working as fast as possible, right? Then once we go from there, then we start thinking about, okay, what can I do to kind of change up some of the things in terms of architecture? How can I split some of these concerns up? How can I, offload things to where they should be offloaded to? And then after that, I hit performance, right? And then I go through and I sort of do that cycle a couple of times, right? I do a few passes on that. So we did a performance pass not too long ago. We need to do another one. One thing that we're not doing that I know is hitting us really hard is we're drawing this entire terrain all at once, right? This is not chunked, and it really needs to be, right? There's no reason for us to be drawing this entire terrain every single time. The other thing that we're doing is for each one of our cascade passes, we are drawing every object on every pass, right? So that is going to be extremely heavy, right? But again, we just wanted to get it working and then sort it out later. So we know this works pretty well because I can, rotate this around and stuff, and it looks pretty good. I think it's starting to really come along, right? Anytime your code draws something new to the screen is an automatic feels good, man, as a graphics engineer. Absolutely. Abso-freaking-lutely, right? So, yeah, that's the basis of where we're at. The other thing that I need to eventually get working is, if I back up a little bit, they're kind of hard to see in the light, but I actually have some dynamic lights here that are kind of just moving back and forth. And they don't actually interact with the shadow map system currently. So we actually need to get that working as well. But that's for another video. That's for another stream, I think. And this I think is where I'm going to probably end this one for today. We do have a few things. I noticed on shutdown we're getting some errors here, right? And this is just me not destroying stuff as I should be. So that's pretty simple to fix, but I can do that at any point. I'm not gonna hold this up for that, right? So let's just make sure we've saved everything. I'm pretty sure we have. So if we do a git status on this guy, this is all the files that we changed in this pass. So let's go ahead and get this checked in. Fix issues around sampler indexing and PBR descriptor refactor is mostly complete. Actually, I can say it's complete, right? We have a few things that we need to clean up in terms of when we shut down, destroying some of those resources. But let me just get this pushed up there. So this is all available in the PBR descriptors feature branch, and it's up there now. So it's pushed so that you guys have access to all of that stuff, right? All that good stuff. All right, let me quickly catch up with chat before we wind down here. And let's see. Do you make use of SIMD for this engine? So that's one thing, we haven't even done that yet, right? We haven't even done SIMD optimization. That's a huge performance boon, typically. So no, we haven't done that yet. It's actually on the list, right? Level of detail, we have mip mapping for textures, but we don't have LOD for meshes. So that's another thing, right? Especially for shadow maps, that's something that we could make heavy use of, right? Let's see. Why is it better to render terrain in chunks to avoid drawing terrain geometry that's not visible to the camera? Exactly, 100%. Yep. And we need terrain level of detail as well. So if we're only looking at, 4 blocks of terrain, why do we need to render the other 256, right? That kind of thing. Frustum culling, yep. So we do have some basic frustum culling in terms of the camera viewport, but the frustum culling for the shadow mapping was a little bit wonk, right? I didn't quite get that right, so that's off at the moment. And so that's what we have to figure out there. All right, and let me just check. Welcome home again, by the way. Thank you for the follow. I appreciate that. Trusticos, thank you for the follow. Let's see. By the way, do you know if it's possible to inject an error into Vulkan call specific force a failure of the 10th call of a Vulkan API function? This feature would greatly simplify the testing of cleanup code. I mean, I suppose you could just write logic to like pass a null handle or something if you really wanted to. But yeah. In my opinion, that's the only way to do it. Premature optimization is the easiest way to murder progress. Yes, 100%. Yep. Does not mean you shouldn't optimize, though, right? Optimization is super important, and we're going to be focusing on that here very shortly. This is an amazing project, by the way. Thank you for that. Appreciate that. All right. So, where we're going to end this today is I would just ask you guys, if you haven't already, to shoot me a follow here and over on YouTube. I would greatly appreciate that. It helps me grow the channel, reach more people, all that stuff. Because the more people that I reach, the better, I think, right? So I really appreciate you guys being here. And yeah, thank you so much. Let me see who I can raid. Let's see. I'm going to raid Pirate Software because he's actually still streaming. So I never get to raid him, so I'm going to do that. All right. Anyways, that's going to do it for me today. Thank you guys so much, and I will see you next time. All right. Peace. Well, I guess in 10 seconds, peace. And for the YouTube side, I'll drop a link here as well. All right. See you guys.
Internet, and you gain an audience of any kind, you are going to be directly confronted with the fear